Good morning, student. Today in this class we will talk about electromagnetic induction. Student, okay? What is electromagnetic induction? Okay. This I will start with an activity, student. Suppose, before I start, I will discuss about the instrument galvanometer, student. Galvanometer is an instrument It is an instrument used to detect the presence of current. If I pass current in a circuit, this needle will show deflection in a particular direction. Okay. Now if I reverse the current, this will show deflection in opposite direction. But if I make the current zero, it will come back to its origin position. This means when a galvanometer deflects, it shows the presence of current. So what is a galvanometer? It detects the presence of current. If there is a current in a circuit, it will show the deflection. This is the use of student galvanometer. Now student, we have a loop like this. And I have connected a galvanometer with this. Okay student. Now there is no current in this circuit, so galvanometer will show zero deflection. Now student, the experiment, one magnet. A magnet is moved toward this. A magnet is moved towards the coil, student. Okay. Now what happens? This galvanometer shows deflection. In one direction. By bringing the north pole towards it. So galvanometer shows deflection means, student, there is a current. When the magnet is taken away from it, again the galvanometer shows deflection. But in opposite direction. But in opposite direction, student. So this means here the movement of the magnet, okay student, brings the current in this circuit. It is movement of the magnet, student. Movement of the magnet brings current. Second, it has been observed that, student, the faster the movement, larger is the current. This is also noted, student. Okay. Now student, when a magnet is moved, actually what is happening, that you have to understand. Already we have learned that a magnet lines of force are there. Okay, student. So when I am moving this magnet, actually what is happening is the magnetic lines of force are entering this loop. And student, one more thing, I will write it here. This means when magnet is moved, magnetic field is changing. Magnetic field is changing. Magnetic field is changing in the loop with respect to time. Magnetic field is changing in the loop with respect to time, student. This, student, gives rise to current. This is the law, student. And this current is also known as induced current. So the basic theme is this: magnetic field must change. Previously you have studied in 9th class, the momentum must change, then the force exists due to change in momentum, rate of change of momentum. Here the magnetic field is changing, student. So this change is very necessary. Even suppose we make the magnet stationary, the coil is moved, then also again there is a current. Means either of them, if they are moved, current will be there. But the basic condition is this must happen. If both are moved together, no current will be there, because the relative motion both will move, there is no change in magnetic field. So this is the theory, student. Now student, one more example. Suppose we have a circuit like this, and here there is another circuit. Now student, what is observed is, as soon as this switch is on, this galvanometer shows momentary deflections. Momentary shows deflection when the switch is on. And similarly, when the switch is off, again it shows momentary deflection, but in opposite direction. So how to explain this phenomenon, student? Suppose the current, maximum current of this is 2 ampere. So before the switch was on, the current was 0. So from 0 to current rises to 2 ampere. During this time, student, there is a current change, and current change produces change in magnetic field. And change in magnetic field gives rise to current. After some time, current becomes constant, no change, so no current. That is why I have written momentary deflection. The same thing happens when the switch is off. The current goes from 2A to 0. Current change in magnetic field, but in opposite, this is the opposite change, student. Current is decreasing. That is why the deflection is in opposite direction. Again the current comes into play. So this is the law, student, that whenever there is a change in magnetic field in the loop, it gives rise to current known as induced current. And suppose the loop is open, student. Say like this, open. Then current will not come, student. But due to the movement of the magnet, there will come induced EMF. Voltage will be there. And as soon as you close the circuit, current will start flowing. So this is the one of the method of changing induced EMF or induced current. Induced, student. And this phenomena is known as electromagnetic induction. EMI. Electricity by magnetic induction. Electricity by magnetic induction, student. Now, student, we have already studied that if there is a current carrying conductor, kept in a magnetic field, current carrying conductor kept in a magnetic field, then force act on current carrying conductor. So this is the current carrying conductor, and this is magnetic field. A force will act on this given by Fleming's left hand rule, student. See, student. Magnetic field forefinger upward, current this way. See, student, the force is acting outward force, and this direction was given by Fleming's left hand rule. Now, students, see the next experiment. This is from previous chapter. Now, there is a magnetic field and a wire. This is a wire of length L. This wire is moved in a magnetic field. Listen what I am saying. This wire is moved in a magnetic field. Then, student, it is observed current starts flowing. If the circuit is closed, current starts flowing, student, known as induced current. Now, student, you see the comparison of this case with this. Here already current was there in a magnetic field. So the motion starts, force acts. Means the wire starts moving, motion. Means the current carrying wire was kept in a magnetic field, so the motion of the wire starts. Here current is not there. The wire is brought in motion from outside agency. The wire is moved. Then current comes. Current starts flowing. If the condition is circuit should be closed. Okay. This is also known as electromagnetic induction, student. And this current is known as induced current. Now we will talk about this in detail. Current in a straight wire. When the wire is moved in a magnetic field. Okay, so this you have to remember. Here I am writing it. Wire is moved in a magnetic field. First thing, if the magnetic field increases, current also increases.